So we'll be distilling ethyl acetate, a mixture of ethyl acetate and bromobenzene. So let's measure those out first. I'll get some ethyl acetate and bromobenzene into this 50 milliliter round bottom flask. Can you read it? Yeah, 50 milliliters. I'm going to add approximately 13 milliliters of each. So let me set up my camera. Under here, I'll use a short stump funnel for this. I could have used the other one, it would have been fun. So let's see, where am I at now? I'll get it to 10 and then I'll do 3. Okay. Ethyl acetate reminds me of the toy you played with as a kid called Balloonies. I don't know if you've heard of that. When I was a kid, it was fun. I think ethyl acetate's the solvent in it. Has kind of a sweet smell to it. Okay, so I'm going to add that 10 milliliters of ethyl acetate first, and then I'll add another 3 milliliters. I'll just pipette this over since it's only 3 milliliters. Already over 1 milliliter, almost to 3. Okay, that's approximately 3 milliliters of ethyl acetate. There we go. Alright, I've got my ethyl acetate. Next up, bromobenzene. I'll do 13 milliliters of that, so I'll have an equal amount of both. Oh, you notice I'm holding my round bottom with this cork round bottom holder. It's how it's indented. It's a nice, easy way to hold a round bottom. Okay, now the bromobenzene smells very aromatic to me. Not a bad smell. It's strong. Now I'll pipette to about 10 milliliters. Okay, and then pour that into the round bottom that already has the ethyl acetate. And another 3 milliliters bromobenzene. Okay. Next, we need to add a magnetic stir bar. Going to stir this distillation. I could use boiling stones, but I'll use the stirring method. So I've added my stir bar. My solution looks pretty good. I saw some mixing lines. Looks like it's miscible though. Okay, and then the next thing we have to do is prepare our column. If I just added this air condenser to this, it would be a simple distillation, but I'm going to make what's called a fractional distillation. I'm going to add a packing. So I'm going to add this steel wool as a simple packing. So I'll just stick a little steel wool in my air condenser. This air condenser is just a straight glass tube. Pushing it down in with some tweezers. Okay, that looks pretty good. Got a little surface area there for the fractional distillation. And then I put that onto my round bottom flask. Okay, so I've got so far round bottom stir bar, air condenser with the packing, so it's a fractional distillation. I'm going to clamp this onto my hot plate, the ring stand, the extension clamp. Notice I added my clamp, I grabbed onto the lowest part. I grabbed onto the round bottom. I like to hold onto the lowest thing, then everything above it is held by gravity in case something goes wrong with the attachment. Next, I need a distillation head. So that's this guy, and then and I didn't talk about this earlier. These have these. There's like a O-ring in there. It's that brown O-ring. When I go over here and I tighten this red cap, it pinches the O-ring and it helps it to hold together, grab onto each other. Okay, and then on the side of my distillation adapter, I'll add my water condenser. Here's a water condenser. The water condenser is really interesting. So the way it works is it's got water can go into that tube, that opening, right? Water can go into this opening right here, and when it does, it's in an outer jacketed area. So it's going to go. The water will go on the outside of that inner tube, and then it'll come out this end. And if you look through here, you see it's just a straight shot here. There's going to be, the inside of this will have no contact with the water. The water is just jacketing that tube on the inside. So the water will be able to cool our vapors, but not have to get my vapors wet. So then I'll tighten this on. It's looking good. And next will be the vacuum adapter. The vacuum adapter is pretty cool too. If I wanted to, I can hook up a vacuum hose here, and it'll draw a vacuum through this area and then through the little guy. That's where our liquid's going to come out. So you can get liquid. You can do a distillation under vacuum with that. I'll tighten that. But the way it's going to work for us is our liquid's going to, our liquid down here is going to boil, and the gaseous vapors will come up, get separated, and then when they hit this area, this will be cooled by water. They'll condense from gas back to liquid, and they'll come and they'll drip out into our 10 milliliter graduated cylinder, and we'll keep track of the volume. And our system is open. It's not closed because there's gas can come in here and there. And now finally on top, I need my thermometer adapter. And that starts with this guy, which has, again, one of those little brown O-rings in there. I stick it right on top. You can see there's that brown O-ring I was telling you about. When I tighten this, it pinches down the O-ring and squeezes everything together. And then the way this next part works, I got another rubber O-ring, a little stronger one. I put that on first, like that, and then I put this cap over it. And the way it works, it's real simple, but it's a good idea, is I'll take my thermometer and I'll stick it through the cap. And when I push it through, it's resisting a little bit with that O-ring. That O-ring is letting it go though. And then when I get it to the height I want it right about there. I can tighten this here and it'll pinch down on that O-ring and really grab the thermometer tight, so now the thermometer won't go up or down. And then when I want to take it out, I loosen it and bring it up. And another thing I wanted to point out is our data isn't going to be that great. This is this thermometer is it's a nice mercury thermometer. They're actually illegal to buy now in California, but these are bought, decades ago, so they're legal to own but not buy. So anyways, we have these thermometers, the mercury thermometers, and this is an immersion thermometer. Can you see that brown line? Let me bring it down here. Can you see the brown line right there? That brown line is the immersion line. So to get an accurate temperature, you should have this thermometer completely in a solution or vapor of a gas to that brown line. Not above it, not below it. And we're not going to have that perfectly here, so our temperature values will have some error, but that's okay. So you can see that immersion line. I'll try to put it down in so it will get most all in there. And we're not working with a very large volume of solvents, so we won't be able to see. This won't be completely coated with vapor dripping off of it, so you're not going to get as accurate a reading, but that's okay. We're still going to get some data there, and then we're going to run our samples through the GCMS and get really good data that way. Oh yeah, and then we're going to monitor the temperature here. So can you see there, it's warm in the lab today. We're almost at like 30 degrees Celsius in here. And okay, now I need to also set up my hoses. So over here, our water aspirator, I normally have the splash guard down here, right? And I usually hook up hoses to the sidearm for vacuum, but today we don't want vacuum, we want water. So I'm gonna hook up a hose to the bottom where that splash guard usually is, where the water runs out. And then this is important, we wanna have a good water-cooled condenser. So I wanna hook this condenser up a certain way. I wanna hook up the water coming out of the tap. I want it to enter the low end. This is the low end, this is the high end. I want it to enter the low end so that the water will fill up the condenser and then drain out the top. If I put it at the top, the water might just fall quickly and not completely fill and not be as good of a water condenser. So put this on. I gotta make sure these are nice and snug, because if you don't and you turn the water on too high, they could shoot off and you've got sun splash in here, the water's shooting everywhere. So we want to avoid that. I'm gonna use 2 hands. Let me pause the video. Okay, I've got a nice tight seal here, and then I'm going to take another hose and hook it up to the top end. Here it is. I'll push it on better with 2 hands. And this other hose I'm going to lead to the sink, so the water's going to come out of the bottom of the aspirator, fill up the water condenser, and then drain out back into the sink. If I had other students doing distillations with me, I could take this, instead of putting it in the sink, put it into their top or bottom of their distillation water condenser. You can daisy chain them together. Let's go ahead and turn the water on, see how this works. So when you turn the water on, we do this the opposite of a vacuum situation, where we use when we want to draw a vacuum for vacuum filtration. When we want to do a vacuum filtration, we turn the water on full blast. For this, we want to turn the water on as minimal as possible. So I'm going to just barely turn it on, and then watch as the water comes around. You see it coming around, and then it's going to fill up and then drain out. Comes around, you see it coming around, and it's going to fill up and then drain out. That is going to be plenty of water, and this water is continually coming through to cool this. That's going to be plenty of water for us. And if I have the water on higher, I'm just wasting more water, and even more importantly, maybe if I have it on high, it's more likely to push these off and have water everywhere, sun splash. And when that happens, you have 2 types of students. You have one student who freaks out and just runs out of lab and lets the water go everywhere, and then the type of student who just walks up and goes, oh, come on, they just go and turn off the water real quick, it's just water. It's funny to see who does what. Okay, so we'll start this distillation shortly. Now we'll begin to stir and heat this. I'll turn on the stir, and you can see there's a little bit of a steel wool on there spinning as well. I can move my round bottom more to the middle of this hot plate. And I want to heat it up too. I'm going to start it off at what it says 200 here and watch it. As I heat this, it takes a little while to get all the way through the fractionating column into the condenser, because the solvent has to be heated, its fumes have to heat the glass of the round bottom above, then the fumes have to heat the packing and the glass air condenser. It has to heat all this, and then it can make its way over and start condensing. So to speed that up, I'm going to wrap paper towel around this. So we won't be able to see it. Maybe I'll wrap just a little paper towel at the beginning, and we'll watch it, and I'll keep wrapping paper towel as we go on. I'll wait until it starts boiling, and then I'll do the paper towel wrap. I got impatient. I turned it up to 400. Maybe I'll just go full blast 500 and see what happens. I'll watch it carefully. Once it starts boiling, I can back off on it. I'm not even sure if that makes it heat faster, or it just makes it stop at that higher temperature. But so far, it's been a few minutes, no boiling yet. Now it's boiling good. And let's see, yeah, it's working its way up the column. Look carefully, you see some, I see solvent dripping there. Oh yeah, it's already starting to come over. I'm gonna turn down the temperature a little bit, go to 300. And let's see, are we gonna see our first drops? I guess I don't need to wrap it. It's pretty warm in lab today. So I think I'm beginning to see, my first volume of solvent. Boom, boom, there's some drips, yep. And this, when it gets to 0.5 milliliter, it's about 0.5 milliliter, I'll read the temperature. I'm gonna say it's 76. So half a milliliter, 76. This data is not going to be that great. It's going to be something to collect though. Okay, this is good. I don't need to wrap it. It's a warm day in lab. I think I'm at a milliliter now again. Yep, I'm at a milliliter, and the temperature is about 78. Okay, let's call it my second graduated cylinder, and I'm gonna get some 3 milliliters in this one. I'll look at the temperature then. For me to see right now, I think it's at about 3 milliliters, and the temperature is about 81 degrees Celsius. So my initial one had almost 2, so I'm at about 5 milliliters. I'm going to switch it over now to a new third graduated cylinder. Okay, so now in my third graduated cylinder, I'm at a volume. I'm going to get to 1 and then see what temperature I'm at 1 milliliter in this third one. I've got a temperature of about 80 degrees Celsius. Okay, it's about 81 still. It's holding at 81. And now I'm at about 2 milliliters in my third one, and I'm still at 81 degrees. We're at about a little past 3, say 3. Okay, now I am in the third centrifuge, graduate cylinder still, and I'm at about, what is this, 6.6, I'd say, 6.6. And the temperature, oh, it rose. Now the temperature is at 90. Looks like we're switching over from the ethyl acetate to the Bromobenzene because the temperature is rising quickly now. We're about 94, and our volume's 7. Let's get a volume temperature again. So let's say 7 milliliters in that third, and we're at 90. What? 95. Okay, 7.4, I'd say. And 104, say 105. No, that's 106, 106. Okay, about 8 milliliters, and temperature is at 156 probably. No, it's 1. Okay, I'm in my fourth graduated cylinder. I'm about to hit the 1 milliliter mark for this one. So when I hit that, I'll read the temperature. 1 milliliter. I think we're at, whoa, it's pretty high, huh? 165. Okay, you can see it's really boiling good in there, condensing off of the top half of the empty round bottom flask and inside of the steel wool and everything, and you can see it dripping off of the thermometer as well. And let's see our total volume here. We are at, on this fourth one, about 2.2 milliliters. And a temperature of 166 still, but 166, 167. Okay, I've had enough. I'm gonna turn down the heat, and I'll get my final reading here. So let's say we're at 3.6 milliliters and 100, 3.6, 167 still. And now I'll turn off the water. I still have the water going slowly, draining slowly. I want to turn that off, and when I turn it off, I have to be careful. This is when a lot of times students make mistakes. When they go to turn it off, they forget which way to turn the water to turn it off. So go slow at first, and I remember if I'm on this side, I turn it that way, okay, water's off. If I turn it the wrong way, I turn it higher, and then the hose can pop off and squirt water everywhere. It usually happens when you do this. If you're on this side of the counter and you're reaching around to untighten it from the other way, you get confused. But now we're good. We can start taking it apart. And this glassware should be very clean because it was just cleaned with distilled organic solvents. So I'll just put that back in my locker to dry.